Friends, it's really a pleasant morning to have this physics class, first class physics class for you people. This is bar magnet, right? Bar magnet. I am going to discuss about bar magnet. So this is one of the core point in CBSE fifth chapter. So I am going to discuss some of the important issues related to bar magnet. So what do you mean by bar magnet? What do you mean by bar magnet? Bar is nothing but you have already seen some of the chocolate bars. It is like that only. A bar magnet is like a magnetic bar which is having two poles. One is north pole and the other one is south pole. A magnet, let me go through the definition. A magnet which is like a rectangular bar that has a magnetic field. A bar magnet which is like a rectangular bar. It is like a rectangular bar which is possessing a magnetic field. It is having a magnetic field. So because of the north pole and south, it is having north pole as well as south pole. Along with that, it is having a surrounding magnetic field. It is possessing a magnetic field. So it is called as bar magnet. It's called as bar magnet. And there were some of the loops which is getting out from the north pole and south pole, these are called as magnetic lines of force. It is creating these magnetic lines of force will create a magnetic field. So these are all the important concepts related to bar magnet. And let me go through the properties of bar magnet. First thing is, the bar magnet is suspended freely. Say for an example, you are having a chota bar magnet, right? So if you are suspending the bar magnet freely, what will happen? The bar magnet tends to align itself towards north south direction. It is aligning itself towards north to south direction, right? So, and the next important thing is, isolated poles never intersect. Never exist. What is meant by isolated poles? Did you know about isolated poles? Poles, you know that there were two poles. One is north pole and south pole, right? But what do you mean by isolated poles? If you cut the bar magnet, if you bisect the bar magnet, it will be bifurcated into two pieces. Right? So after that, if you take a magnet, if you take a piece of magnet, it will not be south, it will not be north individually. It will be like north and south only. So even though if a bar magnet is cut into two pieces, the piece which is coming out from the initial bar magnet will be like north and south pole. It is not like north only or south only. And the third important thing is, like poles repel and unlike poles attract. Say for an example, here there were two bar magnets available. One is north south and the other one is north south bar magnet, right? So I am placing the north pole towards the north pole of the other magnet, and the next indicates the north pole is moving towards the south pole of another magnet. First one is north pole, south pole of a magnet is the north pole of a particular magnet is moving towards the north pole of another magnet, and the next diagram indicates the north pole of the magnet is moving towards the south pole of the magnet. What will happen if the north pole is moving towards north pole? It will automatically repel with each other. And what about the north pole is moving towards south pole? It will get attract each other. So this is the common characteristics related to magnetic poles, right? Okay. And the fourth important point is, not all the materials are attracted by magnet. Say for an example, if I am taking a plastic towards a magnet, whether it will attract? No, it is not like that. And if I am taking a safety pin towards a magnet, towards the north pole or south pole of a magnet, what will happen? It will easily attract. So this is what the point discussed here in this this is what the point discussed here in this platform. And the next important thing is, here is magnetic field lines. Then here is a here's a north and south pole of a bar magnet, which is having magnetic lines of force, magnetic field lines of force, which is extruding from the, which is getting out from the north and south pole of a magnet. So what will happen? It is creating a, because of the magnetic lines of force, field lines of force. If the magnetic lines of force started to getting out from north and south pole, it will create a magnetic field around the bar magnet. So because of the magnetic lines only, field lines only, magnetic field will be getting out. Magnetic field will be produced, right? And the next important thing is, a magnet has north and south pole similar to positive charge and negative charge of a dipole. You have already known about dipole, right? Electric dipole. It consists of positive and negative charges, right? So positive and negative charges separated by a distance 2a. Already we had you have seen in the current electricity chapter. Likewise, in a magnet which is having a north pole and south pole, which is having an intermediate distance, that is mean distance between north pole and south pole. Say for an example, that is 2l. Okay, 2l. Here in magnet we will be having north and south pole, and in that current electricity chapter, there were two charges in a dipole, that is positive charge and negative charge. In between that there is a distance of separation, and that is called as electric dipole. Here it is called as bar magnet. Thank you all for this basic chapter related to magnetism and matter, chapter 5 CBSE, and it is included in chapter 3 of matric syllabus in Tamil Nadu. Thank you.